Question 8 is an awesome question. It goes well beyond what you need to do at GCSE, but it's great in terms of thinking about what a bounce reaction means. So, the thing says 1 mole of a hydrocarbon, let me just focus that, 1 mole of a hydrocarbon with formula CnH2n was burned completely in oxygen and it produced carbon dioxide and water vapor only. Required 192 grams of oxygen. Work out the formula of the hydrocarbon. So, what we've got is, we've got CnH2n. So there's twice as many hydrogens as carbon. Alright, it burns in O2, it tells that in the question, and it also tells us it makes CO2 plus H2O. This is a standard complete combustion of a hydrocarbon. Now, it tells us that we have 1 mole of this, and it tells us that we have 192 grams of that. Okay? What we can't do is we can't bounce the equation because we don't know what N and 2N is. Or can we? We can bounce the equation a little bit. If we look, carbon, all the carbon in the hydrocarbon, let me just see that focus a bit better. All the hydrogen in the hydrocarbon becomes carbon dioxide. And all the hydrogen becomes water. So we know that the number of carbons is also going to be the number of carbon dioxide. Because all of it goes over. So we can say that the carbon dioxide, what we call these big numbers is coefficients. We can say that coefficient is going to be N. The number to balance it is going to be the same as the number of carbons. We can also deduce that if there's 2 N H's here, well, that's how to explain it. There's 2 hydrogens here, right, compared to the carbons, but there's 1 H here and 2 H's in the water. So the number of hydrogens, the number of N, 2N, is going to be the same number of waters. Because 2 hydrogens there and 2 hydrogens there. So what I can also say is that the coefficient for H2O is also going to be N. Right, this will make a lot, this is important later on. But what I know from this reaction then is the number of carbon dioxide and the number of hydrogen is going to be the same. So the number of water is going to be the same. Because all the carbon is going to go there and all the hydrogen is going to go there. And the reason why it's only NH2 instead of 2NH2 is because that 2 basically goes there. Right, that's as much as I can do. There is only one thing I can do with this question. The only thing I can do is work out the moles of oxygen. Because that's the only thing I've been given. So I know that the moles of oxygen is going to be 192 divided by, okay, the MR of O2, which is 192 divided by 32. And I'll find that that is about, it's going to be about 6 moles. Yeah, 6. So, 6 moles. Now, this is where this question comes in great, is I know that I've got 1 mole of this, and it reacted with 6 moles of that. So I know that the moles of the ratio of CnH2n to O2 now is going to be 1 to 6. And that gives me everything I need to balance the reaction. Now, if I call this 6 moles, I'm hesitant to write 6 here because it might actually be 2 and 12 or 3 and 18. But if I just kind of put as a little placeholder, if you will, 6 there, I can use the oxygen now to balance the equation. If I've got 6 O2, that's 12 oxygens in total. That means I've got to find a way of having these numbers the same and it adding up to 12. So let's say they're both 1. Well, that is 2 and 3. It can't be both 1. Let's say they're both 3. Okay, 3 would be 6, plus 3 is 9. We're getting close. 4. If I had 4 CO2 and 4 H2O, well then I would have overall 8 oxygens here, and I'd have 4 there. So I'd add up to 12. That would be what I'd like. So if I rewrite the equation of CH, and I'm going to leave these blanks, I'm going to finish this, plus 6 O2 makes 4 CO2 plus 4 H2O, then my oxygen is balanced. I've got 12 oxygen here, and 4 times 2 is 8, plus 4 is 12. So now I can add the N and the 2N to work out how many carbons and hydrogens I've got. Well, if I've got 4 carbons here, that N is going to be 4. I already know the 2N is going to be 8. Let's just check. 4 times 2 is 8. So the formula of the hydrocarbon is C4H8. So well done if you got that.